That's the talk. That's some of what I'm doing, redundant. That's redundant. So I use the word HIT. I'll describe these. There's a special place in hell for people who read slides to literate audiences, so I try not to do that. If you're illiterate, raise your hand and I'll give you a Braille version of it. No, wrong. If you don't know these terms, just ask. So a lot of you don't know the cost of these systems. A real EHR, electronic health record, with all of the linkages and the like, costs about $300 to $400 million for a large system. But that's only a small part of it. You then have to implement it. And hospitals have up to 3 or 4 or even 500 separate IT systems that have to be connected to the EHR, all the labs and the like. And then they have all of those outside relationships with outside labs, with vendors, with all kinds of connections of stuff coming in and data going out, literally hundreds of insurance companies, and each one of those connections is a potential vulnerability. So the total cost of doing all of that work is big, and people don't think about it that much. But if I buy a toaster and my wife hates it, I throw it out. If I've spent $1.5 billion and then there's a yearly update fee of about 20% to 30%, there's no room for buyer's remorse. You know, I throw out the toaster I don't like. I don't throw out this. So, in the past couple of years, one vendor, Epic, has been cleaning everybody's clocks. They've got about 70% of the large hospital implementations in the past couple of years. 52% of all patients are touched by an Epic EHR. 51% of all clinicians are using an Epic EHR. And so those systems are pretty powerful. In the ambulatory space, in other words, you know, walk-in, basically, until very recently, every doctor who had a brother-in-law who knew VisiCalc and owned a garage built an EHR for an ambulatory EHR. And there are literally thousands of them out there. But they're all dropping like flies because of the new laws on accountable care, meaning that they have to be integrated into the mother hospital of a network. And so all of those individual ones are dying. And what's happening is actually the big, large vendors are also accumulating or building into all of those individual ones. So we're seeing a lot of consolidation. Tragically, despite this consolidation and the great horror of what I study, is that it's chaos. The government was in a position of wanting to encourage everybody to buy and use an EHR. They gave literally $33 billion to hospitals and clinicians to buy these systems. And there was no emphasis until way too late, meaning recently, on data standards. And so we've lost the interoperability, which was one of the key goals and one of my key frustrations in all of this. And for those of you who remember some economic theory, this is called regulatory capture, where the powers that be in the federal government were simply following the ideas set up by the industry, a place called HIMSS, Health Management Information, I can't remember, Security System. And they've sort of written the laws that we've been operating on. And I've called it the foxes are the architects of the hen house in this regulatory context. So we've talked a little bit about that. And when I was describing these vulnerabilities of the EHR having to connect to so many different systems, one of my computer engineering students said, no, Professor Koppel, to the extent that those systems talk with each other, it's really 500 factorial. And I said, well, that's grotesque exaggeration, but the point is well taken. So I'm going to spend most of the time talking about how crappy the systems are. This is a drop-down menu to move a patient 15 feet from the ED, that's emergency room, to the X-ray suite. And one of the options is helicopter. Another one, I got this one from a doctor who said, does anybody parse this goddamn list? You know, the probability that an 83-year-old needs a fetal monitor is low. And in terms of the lack of standards, I picked the easiest thing imaginable that you would want, systolic over diastolic blood pressure. And this is some of the ways, I don't have a pointer, it's okay. So the top three here make total sense, ways of displaying systolic over diastolic. If you picked any one, that would be fine, and you stuck with it. This one was designed by a programmer who knew the word diastolic comes earlier in the alphabet than systolic, and then separated them by two, that should be two screens. And if you know anything about medicine, you know you need to see these things contiguously. And then all of these others are entirely legitimate pieces of information that a doctor might want to see, but first you want to see those two darn numbers. And it goes on. In fact, when somebody complained that these were rare, I had a bunch of physicians in the office who said, no, you forgot stable as one. And I went, stable? And he said, yeah, but I don't know stable high or low or whatever. So you can see it's chaos out there. This is what I call interoperability. This is literally, somebody took a screenshot, I don't know what to call that, a shot of the screen. So for those of you who have children or know something about it, this is a growth chart. We actually found examples that go back to the 1840s in medical textbooks. The top line shows stature or height. We call it stature until they're old enough to stand. And by looking at the two together, a pediatrician can see this, what they call a dip in the line, and it suggests one of several things, either a gastrointestinal problem, child abuse, starvation, or something like that. It's immediately evident. But with the magic of computers, the system now displays in separate screens, I kid you not, the two charts separately, so that it's almost certain that the pediatrician will miss that dip in comparison and fail to diagnose the kid. So what I have seen is an attempt at data integration where I swear to God, and I have pictures of this, but they're old, of two screens duct taped together so the doctor can see the data at the same time. So this is a common issue. It's the default display of dosages, 5 milligrams, 4 milligram, 1 milligram. Now, you're a young doctor. You've been on this rotation for 4 days, 3 days. It's 4 o'clock in the morning. This is the display of the medications that you see, of the dosages. And you figure 5 milligrams is standard, 4 milligrams is for shorter people, 1 is for adjunctive therapy. No. The reason this is displayed this way is the English alphabet. The word 5 comes before the word 4, comes before the word 1, and we asked the vendor to fix it. And they said, we can drug by drug, but you have to promise there'll be no changes. And we said, look, Pfizer comes out next week with the 4.3 sustained release. We have no control over that. And they said, you'll have to wait for the next version. That was 2003. This is still the default display. For what it's worth, it could be that 2 is the normal dosage. There's no logic other than the English alphabet. So here's one where you type no allergy, and then maybe you took a computer science course before you became a doctor, and you realize that it's really no known allergy, so you click that. Excuse me. The computer interprets that as multiple allergies. And everybody then learns that multiple allergies equals no allergies. But of course, there are people with multiple allergies. Here's another one. All baby weights are given in kilograms. Always. But maybe to help the doctor talk to the mom, the computer program changes it to pounds, but it doesn't show the metric. What happens next is that the next pediatrician kills the baby by giving 2.2 times the dose. This one is just self-explanatory. You know, you say, well, put the positive. Positive in medicine means bad data. Sorry. Fix it. Deep vein thrombosis is a blood clot in your leg. And it's a very big problem of people who are lying around for a long time. It's also sometimes called economy class plane disease. So it's where you're stuck in some position. And people in hospitals with like cancer or surgery who are prone for a long time get these things. That's better. As a result, they give blood thinners to people who are suspected of developing these things as a very common prophylaxis. And to ensure that every doctor do this, the EHR demands that you order this prophylaxis before you exit the software. The problem is that these blood thinners are incredibly common, and like a third of your patients may already be on these blood thinners. So if you add more, you're going to cause them to bleed to death. But you cannot get out of the program unless you order this prophylaxis. So you've got to double dose the guy on blood thinner, meaning they're going to bleed to death. And this is the workaround the doctors have. They order it, the double dose, and then they have to go back into the system and cancel one of the doses to prevent the guy from bleeding to death. Now, you can imagine hospitals are messy, busy places, and the possibility of being called away before you get back into the system. I don't have to finish that. This is a great example. The ED, which is the ER, a doctor comes with a patient who's been shot 3 times, dying in front of the triage nurse. They take the blood pressure, which is 20/12. The doctor enters the blood pressure into the computer system so that he can order medication, blood pressure medication, to try to save this guy's life. Doctor puts in 20/12. The computer says, nobody has a blood pressure of 20/12. The doctor says, ordinarily you're right, I agree entirely, but they do if they're dying with 3 gunshot wounds in front of the ED. So what the doctor has to do is enter 120/80 and then order a whole bunch of vasoconstrictors to get the guy's blood pressure up. And then a week later, he has to answer to the medical board why he ordered these massive drugs for the patient. Nurses and doctors have dozens of passwords that they have to remember. Each of the machines that they use requires a different password. They have to change so nobody can remember it. And they're supposed to work in teams, right? This whole teamwork thing. But a lot of the software security is set in such a way that the nurse can't see what the doctor is seeing because the doctor has greater privileges, greater authority onto the system. So the only way that the clinicians working as a team can do is, of course, to share their passwords. And I don't have to explain the issues there. So if you go into the supply closet or the med prep room in any hospital, you will find this forest of stalactites I guess that's a mixed metaphor, of everybody's passwords so that people can actually do their work. This one I don't have to touch. It comes from my colleague, Sean Smith. Infusion pump. In the old days, right, they hung that bag and it drip, drip, drip into your arm. Now it goes into a computer called a smart pump because it has a library of meds. And they have an upper bound of patient weight when the drug has to be weight titrated of 350 pounds. But as my colleague who works in UW-Madison said, nobody intended patients to live a life of kielbasa and beer. So she's got a lot of patients at like 600 pounds. But you can't program 600 pounds into that and give the med. So the nurses and doctors have two horrible alternatives. Either they lie to the library that it's a different drug with a different drip rate so that they can get the correct drip rate for that guy's weight, or, equally horrible, they connect two pumps and split the dosage across the two pumps. Both are horrific safety-wise. But, so the question is, why doesn't somebody, make the pumps work? And while we're talking about smart pumps and security, it is possible to stand across the street from a hospital with a little device that will break into the hospital's Wi-Fi. And you can say to the hospital, put $1 million in my Cayman Island account, or I will press this button and turn all of your pumps, smart pumps, into free flow, which would immediately kill all of your patients, because all of that drug would just zap right into them. They're gravity fed. Talk about security. Another thing that I recently wrote about is something called cut and paste within the document. And cut and paste is exactly what you think it is, or copy and paste from a word processor. And it has uses. The patient who was a 43-year-old presenting with severe headaches yesterday is still that way today. But what happens is it creates what's called chart bloat, which is you take a 3-page note and you turn it into, literally, no joke, a 3,000-page note, which means that the next doctor looking to find information about your patient basically can't find it because it's obscured in 3,000 pages where you keep on repeating the same things over and over again. One of my colleagues had a patient who came in from a car accident, comatose, immobile, and when that patient walked out of the hospital 2 weeks later on his own steam, mixed metaphor, until 10 minutes before he left the hospital, his chart read comatose, immobile, and the like. It was only when they had to finally fix that. But if you're the next doctor looking, you're looking at that. Also, of course, you can repeat what the previous doctor did before and then bill CMS or your other insurance. And here's a major security issue. The software generally does not show the author of the original comment. Now, you can hire a computer forensic specialist to figure that out, but that's stunningly expensive, and few can do it. And the software itself has a function called Make Me the Author, wherein a doctor might tell a nurse, listen, update it that we've changed the dosage to whatever, or that the patient's wound is healing a little better. But with this Make Me the Author function, the nurse can write in the name of the doctor, or one doctor, a young doctor can write in the name of a more experienced doctor, and the computer sort of fudges the history. And you can imagine what this does in terms of making the medical record incoherent. And in terms of liability and the like, you cannot really reproduce what the doctor saw at 2 weeks ago on Thursday at 4 o'clock because the note is infinitely malleable. And also you don't see those. And so when you print it out for the court trial, the printed version bears little relationship to what the clinician saw at the time when she or he was making a decision. I really try to follow my rule of not reading. That's a great function. So how did we arrive at this mess? The various organizations, my own American Medical Informatics Association and HIMSS, the trade group of the vendors, have had this idea of obliging hospitals and clinicians to buy these systems for about 25, 30 years. And when the ARRA came about at the beginning of the Obama administration, they took a program that had been put up by the younger Bush, and they flooded it with money and with regulations that required that everybody buy these systems. Now, they did a survey of the hospitals, and as you know, I'm a sociologist, I actually know something about surveys. And the survey found that hospitals needed those things, more money, tech support. And so that was the justification for the structure of the funding mechanism and the certification process. And it was only a few years later that I got a chance to see the survey that generated those numbers. And sure enough, none of the questions that any rational human being who cares about using software would ask, none of those questions were included. So there were no questions about, how clunky the stuff was, whether stuff worked, all of those issues. And so they found what they wanted to find to justify the system. And it perpetuated this view of doctors as those creeps, which is generally not true. I mean, come on, how many doctors have had iPhones, the first on their blocks, and want to play with toys? So we make a series of assumptions about HIT. You're supposed to laugh at the last one. So let's reject that one. So everybody always says, don't you agree that HIT is safer than paper? And I say, absolutely. It's also safer than wet cuneiform tablets, pigeons, smoke signal. No, it is a dramatic improvement over paper. I'm not a Luddite. I don't argue for going back. I just think that the quality of the software is so much less than what it could be. It's got state-of-the-art interfaces circa 1999 or something, and it's, you know, it's people's lives. I was at a session when this guy said this, and the guy is one of the heads of a group that I'm on. Nobody reacted. So what I'm going to talk about now for a few seconds is the idea of the software in context, which to you doesn't seem at all strange. You're not intimidated by the magic of software, but there are a lot of people in healthcare who just think software will come and magically throw this safety net over everything. But they don't consider all of these issues. ONC is the Office of the National Coordinator, the regulator. HealthTech is the law that was passed that enabled the funding and set up this certification system. So this is a model that I developed, which you may find of interest. So you introduce new HIT, which goes through the social system. This is standard socio-technical analysis. It also goes through the existing system, and it affects the way the HIT is actually used. Now, here's why I'm famous. I added an arrow. I added back the recursive interaction between the HIT, then changes the social system, which in turn affects the HIT itself. And so this is a model that I think has a lot of applicability for our understanding of healthcare IT. And this is my subtle way of talking about the current state of quality and safety. And this is a question of where we went to, how we started this. MU is meaningful use levels. Missy. The ONC literally issued a call for people to report happy stories and happy videos of how joyful they are with their healthcare IT. And I'm going, don't we learn from examples that don't always work out perfectly? I mean, I'm going to split this in half. The largest vendor has a guide to telling your nurses and doctors what to say as you're struggling with the new software and cursing. And so the question was this just at one hospital system? You know, and so I shouldn't blame the vendor. This is instead of making the software good, you tell the workers what to say to people. So I then found it at 3 other hospitals, suggesting that it's either spontaneous invention or somebody was guiding the sales. All right. So HIMSS is the traded, and they have stages. And as you get higher and higher in your HIT, you can advertise to the community that you have improved safety. So you get these stages on the left, and here's my interpretation of what each of those stages represents. There are actually 7. And I mean, And they advertise them. They go, we are a HIM stage 7 hospital. So here's, as we move into the close here, when we ask for improvements in the software, they say, and I kid you not, I'm sorry, we can't change that software, it's hardwired, which is my favorite oxymoron. So this is a typical request for changes. But remember that clinicians have studied a lot of things, but not computer science and not computer engineering. So when something doesn't work, their first question is, did I forget my password? It says, by the way, the most common question to all help desks is, what is my password? And all of those are legitimate questions. My friend Gordy Schiff at Harvard, when he shifted to Harvard, he called up the help desk and he said, this half of my screen that I need for my patient is grayed out. And they asked him a series of questions. Where did the patient come from? What is the size of your screen? What is the pixel and the ratio? How many clicks did you make before you got in here? And he tried his best. He's actually the author of some seminal work on healthcare IT. And finally, they called him back and they said, I'm sorry, we can't reproduce the problem. And he called again and again for problems like that. And each time they said, I'm sorry, we can't reproduce the problem. So one time they called him and he expected, they say, holy mackerel, you're the Dr. Gordon Schiff who wrote all of these essential articles about how to use HIT. Now what they said is, Dr. Schiff, we're sure you're well-intended, but all of the problems that you've called about, we can't help you. So we'd like you to not bother us unless you can give us problems that we can reproduce and solve. So when you call the help desk, sometimes they define the problem as solved, even though you're still struggling with it. If it does it's elevated to the Chief Medical Information Officer and then to the vendor. Now the vendor, and this applies for all software, okay? The vendor's first reaction is, you screwed up, right? And very often it's true. These systems take 4 or 5 years to implement. They have thousands of connections. You have new residents every July. They're on a new rotation every month. There's a lot of learning and training that has to go on. They're also very willing to train for a few $1,000s a day. Now, if you make it to the vendor list, they again look at that. And of course, if it's going to kill 5,000 patients by Thursday, they're going to jump on it and fix it. Or they might see that as a profit center. And customers, by the way, is not number of patients. Customers is number of hospitals or doctors to solve. And they have to make business decisions. And then there are other issues. So a lot of these systems are built on millions of miles of spaghetti code and thousands of tables, the names and documentation of which have died in the vast dustbin of history. And so very often they'll say something like, we can fix that, but you won't be able to order Band-Aids for the next 7 weeks. And sometimes when you come up with a really good idea, they say, that's wonderful, we'll jump right on it. But they realize that if they hold it off for the next upgrade, they can make money on it. And by the way, if you do any of the work on it, they get to keep it. So that's the usual development cycle and testing. So if you hit your request for repair and it's not an emergency or patient safety, you will get it at the fastest 30 months later. So, how to fix it? One, we need to allow doctors and nurses and the others to report problems with the HIT and do it immediately. Currently, the law reads that if you take a screenshot and send it around and it says something nasty about the software, you can be sued for millions upon millions of dollars. It's a non-disclosure clause that I wrote about. So we need a third party. We need to change the two laws, the two contractual clauses in the contract. One that says you can't talk about or show how crappy the software is, and the other is a law that says hold harmless, which is if you inform us of some screw-up in the software or a safety vulnerability, we are not responsible. We simply create a tool that is used by you, a learned intermediary, with unique medical knowledge and unique bedside knowledge. We are not responsible. Even if 2,000 people have told us that the software changes a baby's weight from kilograms to pounds and doesn't show the metric. And then forcing everybody to buy these systems in order to get the reimbursements and the incentives is a little nuts. Many hospitals will regard the nurses' expressed enthusiasm for the software as an indication of their good teamwork and good work. I know of no hospitals that have punished doctors for bitching about it, but I do know of hospitals that have punished nurses. Done before my time. Thank you.